Recently, we have been looking at solving triangles, and specifically right triangles, and we would look at something like this, where we would try to find all three sides and all three angles, and then we would, could use, for example, here, I could say cosine of C is 8 over 12, and then we talked last time about how to use inverse to be able to find the angle. So we want to continue to look at triangles today, but we want to look at something a little different. What happens if we have a triangle like this? Now, right away you can see it looks a little different. And if we use what we know about triangles, we know that the angles add up to 180, then we subtract 32, we subtract 100, we get 48. So this angle here is 48. So obviously, we do not have a right triangle. And if we don't have a right triangle, we cannot use Pythagorean theorem. We cannot use SOHCAHTOA. So how can we use, or how can we solve this triangle to find, if I label this ABC, to find this side A? We can't do that because all of those tools that we have are only for a right triangle, and we no longer have a right triangle. Now, before I move forward, I want to back up and refresh your memory on a problem such as this. If you have two fractions that are equal, you can solve these by doing something that is called cross multiplying. And if you remember cross multiplying, you cross multiply, so you take x times 7, which is 7x, 2 times 4, which is 8, and then you can solve by getting 8 sevenths. So this cross multiplying thing is going to be really important as we use the law of sines. And that's what we want to talk about today. How can we solve this triangle that doesn't have a right angle? We are going to use what's known as the law of sines. Now let me show you the law of sines. And here it is. So the law of sines is the sine of A over A equals the sine of B over B equals the sine of C over C. And these are always equal for every triangle. Now, as we show this, I want to think of it this way. This is going to be the sine of an angle divided by the opposite side. That's really what you want to think about. Okay? It's the sine of an angle divided by the opposite side. So let's look at an example. And you're not going to use all these. Just like our sine, cosine, and tangent, we don't use all of them every single problem. Sometimes you use A, sometimes you use B. It just depends. So let's go back to this one. And I'm going to label these. I think I labeled them already. Back here, there we go. We labeled them as A, B, and C that way. So what this says is we have the sine of A, which is 48, over A is equal to, and I could use either one of the other two. So I could say the sine of 100 over 13. Notice this case, I'm not going to use the 32 and I'm not using the 7. That's okay. Now, to solve this, we are going to, as we just said, cross multiply. So this is 13 times the sine of 48 equals A times the sine of 100. And if we put this in the calculator and we do 13 sine of 48, we get 9.661. If I do the sine of 100, I get 0.985. So this is 0.985 times A. So now if I'm solving for A, all I have to do is divide both sides by 0.985. So if I take 9.661 divided by 0.985, I get 9.808. And so now I have solved that triangle. So we're going to use this ratio as the mathematical word for it that we're going to write. We're going to cross multiply, and then we're going to solve. Because everything we've known up to this point, Pythagorean theorem, SOHCAHTOA, doesn't work because it's not a right triangle. So another one. So here's our triangle. The first thing I'm going to do is I'm going to label it as ABC. So I'm going to say this is A, this is B, this is C. And when you look at this, there's really only one thing we can do. We know the sine of 100, the sine of an angle divided by the opposite side equals the sine of an angle divided by the opposite side. Well, you notice I don't know angle A and I don't know side A. That's not going to help me. But I don't know angle C, but I do know side C. So I get to here. So now I'm going to cross multiply. So I get 9 times the sine of 100 equals 15 sine of C. So in my calculator, I will take 9 sine of 100. And then to solve here for C, I'm going to need to divide by 15. So I'm going to divide by 15. And I get 0.591. Now notice, like we talked about previously, any time you're trying to solve for an angle, we have to use inverse, just like what we looked at last time. That was the last section. So we go to inverse, 0.591. So I go back to my calculator. You can see a lot of calculator work here. So I go inverse, 0.591. And I get 36.228. So that's my angle C, 36.228. Now, to find angle A, I have to go back to my calculator, and I need to subtract 100 minus 36.228 and get 43.772. 43.772. And now I have one more step. I need to find what is side A. I got to use law signs again. So now I have the sine of 43.772 over A. And I'm going to use the same one as before, the sine of 100 over 15. So now we can go away from our triangle and just solve this. We're going to cross multiply. 15 sine of 43.772 equals A times sine of 100. So I take 15 times sine of 43.772. And then I'm going to divide by the sine of 100 to get what A is. And I get 10.537. And now I have found all my sides and all of my angles. Remember, anytime you're solving for an angle, you must use inverse. But on all of these problems, we have to use this ratio, we have to use these two fractions. We have to cross multiply. Notice, we never use all three of these in a row. We never use all of these like that. We pick two. We either do A and B, or B and C, or A and C. You only pick two of them to solve. We are now ready to do our homework over the law of sines.